Okay, so let's talk about how to solve exponential equations. Before we start solving them, first you need to recognize when you actually have an exponential equation. So an exponential equation is an equation where the exponents have variables. Okay, so let me give you an example. Let's say something like 5 to the 2x, all right, power is equal to, let's say, 12. Okay, so this would be considered an exponential equation because you notice the exponent here has variables. Okay, so the exponent here has variables. Okay, so that's when you have an exponential equation. So anytime you have an exponential equation, typically these are the rules that you would follow, right? So the first thing you want to do is you always want to try and get the same base if you can, right? So some questions, step one here will be possible. Some questions, it won't be possible, okay? So I'll explain how you would solve an exponential equation, right, when you can do step one and also when you cannot, okay? Okay, so let's take a look at this question right here, right? So we need to solve, right? And then you should recognize that since the exponent has variables, this is an exponential equation. So anytime you have an exponential equation, what you want to do is you want to think, can I get the same base? Is there any way for me to get these values, all right, to be the same? Okay, so that's step one. So in this case here, yes, I can get these numbers to be the same if I use a base of 2. So I'm going to change this 8 to 2 to the third power. So the 2x minus 1 is still outside there. 32, I'm going to change the 2 to the fifth power. Now if I follow exponent rules, I'm going to distribute these exponents, multiply them. So I'm going to get 2 to the 6x minus 3 is equal to 2 to the fifth power. Now that we've gotten the bases to be the same, right? If the bases are the same, right, then that means we can set these exponents, all right, equal to each other because they have to be the same. So then this means that 6x minus 3 now, we can make it equal to 5, and then you just solve for x, okay, or whatever variable they're using. So we get 6x is equal to 8 divided by 6, so x is equal to 8 divided by 6, and you want to simplify that fraction, so that's going to give you 4 over 3. Okay? Okay, let's take a look at the next example here. So in this example right here, right, so we have 81 to the x plus 2 power is equal to 1 over 27. So remember, anytime we have an exponential equation, what we want to do is we want to think, is there any way for us to get the same base here? Okay, is there any number we can use so that we'd be able to get the same base? So in this situation, yes, I can get the same base. I'm going to change this 81 here. This is going to become 3 to the fourth power. The x plus 2 is still on the outside right here. Now this 27 first, I'll move it to the top. So it'll become 27 to the negative 1 power. Now 27 I know is 3 to the third, and I have the negative 1 out here. So then basically this is going to equal 3 to the negative 3 power. Now that I've got the same base, the bases are the same. Remember, after you get the same bases, you can make the exponents equal to each other. So in this case here, when I multiply 4 times x and then 4 times 2, I'm going to end up with 4x plus 8 is going to equal negative 3. Then we just solve for the x. So 4x is going to equal minus 8 on both sides, negative 11. So x is going to equal negative 11 over 4. Okay? Okay, so now let's take a look at an example where we cannot get the same base. Okay? So let's take a look at this example right here. So first of all, let's say I minus 8 on both sides, right? So then I would get 3 to the x minus 1, right, is equal to 11. Now if this is a 3 and this is 11, it is impossible for me to get the same base, right? So it'll be impossible to get the same base. So whenever you cannot get the same base, right, and it's an exponential equation, that's when you need to remember that, oh, I'm going to need to either log or natural log both sides. So remember, if you cannot get the same base, you'll need to either log or natural log both sides, right? So you only need to use the natural log when this is an e, okay? So in this case here, we need to log both sides. So the reason why I log both sides is if I turn this into a log, right, then I can use log properties. So log properties say I can take this exponent and move it to the front. So when I do that, I'm going to end up with x minus 1. All right, I would put it in parentheses because this is one quantity, times log 3 is equal to log 11. Now we just solve for the variable now. We just get x by itself. So I would need to divide both sides by log 3. So I would get x minus 1 is equal to log 11 divided by log 3, right? And then I'm going to add 1 to both sides. So my final answer, right, I'm going to end up with x is going to equal log 11 divided by log 3, right, plus 1. Okay, so I put x equals. Now, usually these are non-calculator questions, so you would just leave your answer like this. You wouldn't be expected to simplify anymore. If it happens to be a calculator problem, then you can just put this in the calculator and then round to 3 significant figures. Okay? So let's take a look at another example here. So first of all, here's something very important. Before you log or natural log both sides, you want to make sure that you want to get the term with the exponent that has the variable by itself, right? So let's say this problem right here, right? I don't want to, at the very beginning, right? So I see the e here, so I know I need to use the natural log. But you don't want to do this at the very beginning, okay? You want to get, this would be incorrect. You want to get this by itself, then you natural log both sides, okay? So just make sure the term with the exponent that has the variable, make sure that is by itself before you log or natural log both sides. So minus 4 on both sides. So I have e to the 3x plus 2 is equal to 12. So obviously I'm not going to be able to get the same base because that's an e and this is just a number. So if this is an e, this is when you use the natural log, right? So you have to natural log both sides. So when we move this to the front, you're going to end up with the 3x plus 2, right? This is one whole quantity, times natural log e, right? So natural log e right here, remember this was a special case. This really equals 1, right? So you have to memorize that. This is very important for you to remember. Natural log e is equal to 1, is equal to natural log 12. So basically this means that we just have 3x plus 2 is equal to natural log 12, and then we solve for x, right? So minus 2 on both sides, then divide by 3. So x is going to equal natural log 12, all right, minus 2, and then we divide it by 3. Okay? And then you could just leave your answer like that, right, if it's a non-calculator question. All right, so let's take a look at this question here. So this would be considered an exponential equation because we have exponents with variables, right? Now, this is a very special type of problem. When you see this, this is a question where we consider this to be in quadratic form, right? So if I kind of manipulate this real quick, so let's say I make this e to the x to the second power, right? So this would give, if I multiply these exponents, I would get e to the 2x minus 3e to the x plus 2. So you notice here, if I do a quick substitution, right? So let's say I say, if I make e to the x equal to the letter u, well, e to the x right here and e to the x, I can replace with the letter u now. So I would get u squared minus 3u plus 2 is equal to 0, right? So you notice this is a quadratic, right? So this is what we mean by quadratic form. So this exponential equation is in quadratic form because we can treat it kind of just like a quadratic. So we would factor this. So you would factor this using whichever factoring method, right, you're comfortable with. So minus, we have a 2 minus 1, right? Double check it, make sure you factored it correctly. It looks correct. So then we have u minus 2 is equal to 0. U minus 1 is equal to 0. So that means u is going to equal 2. U is going to equal 1. Now we're not finished though. you need to substitute back, all right, these values, all right, with the e to the x. So we know e to the x is u, so e to the x is going to equal 2, and e to the x is going to equal, all right, 1. Now we need to solve for the x. So we need to, all right, ln both sides because you have this base that's an e. So then we're going to get x. Remember natural log e, right? Ln e, this equals 1. So 1 times x is just x. So x equals natural log 2. Same thing here. I natural log both sides. All right, this really just equals 1. So I get x times 1, which is x. And I get natural log 1. So this one you actually should simplify further. We know that this actually means that the answer would be 0, right? Because e to the 0 power will give you 1. Okay?